Alrighty, so today I'm going to be talking about reaction order, and we're going to be covering zero order, first order, and second order. So zero order is kind of the simplest, and the rate reaction, the equation is going to look like the rate equals k times the equals k. And basically, in a zero order reaction, if you change the concentration of your reactant, there is no change to the rate. So these are kind of sad. And then on a first order reaction, the rate law or rate equation is going to look like K is the concentration A. And I'm going to write to the first, though we usually would not write this because there's an implied 1. And this means if you change the concentration of A, then rate changes proportionally. And by changing proportionally, that just means if I double the reactant, then the rate is going to double. And then we have second order, so the rate equation is going to look like rate equals K, A squared. So here's where my order is coming in. This would be A to the 0 if we thought about it. We don't have to write that because anything raised to the 0 power is 1. And then if we change the concentration of A, the rate is kind of doubled. Rate change doubles. So if I double the concentration of A, the rate goes up by a factor of 4 because it's squared. So that's kind of how reaction order breaks down in a simple definition. So when change is squared, my bad. So if it's a reaction of 1 and I double it, then it's going to go to 4 because of the squaring of this number, and the rate will reflect the equation. But in general, when the concentration changes, the rate is going to change as a square of the concentration change of that, whereas not being proportional. So that's reaction order. I hope that was helpful.